Hello everyone, my name is Monit and today's session we will start paper 5 planning analysis and evaluation of Feb March 2020 paper code 5.2 question number 2nd. Those who have not attempted or have gone through the question number 1 have also uploaded the question number 1 of the same series. Today we will solve question number 2. Before going on, please read out the instructions given to you. Okay. Question number 2 says, a student investigate the discharge of a capacitor through a resistor shown to us. This is the supplied voltage, this is the key, and it is attached with a capacitor and with an ammeter with a resistor parallel to the capacitor. The student initially closes the switch. This switch is closed and charges the capacitor. The capacitor is charged by switching on the circuit. The switch is then opened and a stopwatch is started. Now this is opened and a stopwatch at the same time is started. The capacitor starts to discharge through the resistor because it is connected with the resistor, so it will get starting discharging. At different times t, the current I is measured. With the stopwatch we are measuring the current, which is given us by the relation I equals to E by R, e raised to power minus t upon RC. Here the E is the EMF of the power supply, C is the capacitance of the capacitor, R is the resistance of the resistor, where T is the time. A graph is plotted of ln on the y-axis against T on the x-axis. Determine expression for the gradient and the y-intercept. The same type of questions are coming in the each and every year. So the following method is by giving this equation, using this equation, we can take log, that is the ln base E on the both side. So if I take the ln I, it will be ln E by R plus ln E gets cancelled out and I get minus T by RC. By rearranging, I get ln I equals to minus 1 upon RC into T plus ln E by R. Now comparing this equation, if you know the features of, if you have studied about the logarithm, it will be very easy for you to rearranging this equation and comparing with the equation of straight line, that is y equals to mx plus c. So it is ln I on the y-axis, so this is y, this is mx plus c. So c is the y-intercept, so ln E by R is my y-intercept, gradient is the m, that is minus 1 upon RC. So the A part we have completed by using the knowledge of logarithm. Simple. Now the next part, the table is given to us with the value of T in second and I in microampere. We have to calculate and record the values of ln I in table 2.1. Include the absolute uncertainty in ln I. Here what we are supposed to do, we have to complete this with the absolute uncertainty. Now many students have any doubt regarding the absolute uncertainty, so that should be cleared. That absolute uncertainty is calculated by taking ln of the maximum value, that is 46 plus 2 is 48 minus ln the normal value or the mean value, that is 46. So this is ln A minus ln B, so I can write ln A by B. So if you calculate this, you will get answer 0.04 up to 2 significant figures. I have taken the values up to 2 significant figures and this up to 3 significant figures. And this is ln 46, that is 3.83, and this is the absolute uncertainty by using this formula. So you can check each one of the values. I have already completed this table 2.1. You can use the calculator by using to calculate this value. This is what ln 46 plus minus by this method. You can check the values if you want. So this is of 2 marks. Now plot a graph of ln I against t second. Include the error bars for ln I. In the C1 part, in the next page, on the opposite page, I have drawn the graph. If I minimize it, you can see the graph in one go. Okay. So this is the graph. Here it is in t seconds. Here it is ln I. So what I have done is I have mark the points. First of all, you are supposed to mark the points according to the values given to us in the graph. So these are the dotted points are my values. With the error bars means I have taken the error bars also. That is the plus minus whatever we have get in the table, that you have to mention it here. So these are the error bars what we have done. Let us see any one of them. So if we check, for example, let us see for 36. So at time equals to 36, it is 3.33 plus minus 0.07. So let us go to the time at 36. So this is 36 and the value at 36 is 3.33. So this is 3.3 and this is 3.4. So each one will have 3.31, 32, 33. So this is 3.33 at 36. So I have plotted this point as 3.33 at 36 seconds. And with the error bar 0.07. So 0.01, 02, 03, 04, 05, 06, 07 plus and minus as well. You can count 1, 2, 3, 4, 5, 6, 7. So 0.07 here also. So in this manner you have to calculate, you have to draw the error bar for each of the values given in the table 2.1. So the C1 part we have done. Draw the straight line of best fit and the worst acceptable straight line on your graph. Both lines should be clearly labeled. Now what we are supposed to do is we have to draw the best line fit and the worst line fit. So I hope you all know how to draw the best line fit. So this red color line is my best line fit, which is very close to the plotted point. So it will have very close relation with the plotted point. This is at the lower level. This is exactly coinciding. This is slightly upper. This is slightly lower. This is coinciding and this is slightly near to it. So I have drawn a line of best fit on the graph. For the line of worst fit, what you are supposed to do, you have to take the lower value of the error bar in your best fit line and the highest value of the error bar of your best fit line at the last value. So this is the last point, first point of the error bar, and this is the last point. By joining these 2 points, I have drawn a line of worst fit and line of best fit clearly labeled. Okay, so the blue color line is line of worst fit and the red color line is line of best fit. You can get this PDF, my handwritten notes, which I am explaining right now. You can download the PDF of this video. The link is provided in the description. How can you download the PDF? Okay. Also, for the third point, determine the gradient of the line of best fit. Include the absolute uncertainty in your answer. This is very important point here. How to calculate the gradient. So what I have done, in order to calculate the gradient, I have to take the points on the line of best fit and the line of worst fit in order to calculate the absolute uncertainty. So what I have done is I have taken on line of best fit as x1 y1 and x2 y2 as 5, 3.79 and 47, 3.2. and for the worst fit line 5, 3.73 and x2, y2 as 51, 3.2. So these points you have to mention in the graph. So if you look at the graph, I have mentioned this x1, y1 for the best fit and x1, y1 for the worst fit, and that should gradient be at least cover the half of the graph. This is very important, students. The line which you are showing for the gradient should cover the half of the graph. So it is covering my half of the graph, and the points are also mentioned on the graph for the values which I have taken for the calculation. So gradient for the best fit is y2 minus y1 upon x2 minus x1. So the values are already written here. By putting the values and calculating, I got minus 0.014048. So taking it up to 3 significant figures, I round it to minus 0.014. This is for the gradient of best fit. Similarly, gradient for worst fit using the same y2 minus y1 upon x2 minus x1. By putting up the values, I get minus 0.011522. You can calculate with using your calculator. Now the absolute uncertainty is the mod of gradient of best fit minus gradient of worst fit. So by putting up the values, I get the value up to 3 significant figure, rounding off 0.003. So the gradient comes out to be minus 0.014 with the absolute uncertainty plus minus of 0.003. So this is how I calculated the C third part. This is the graph which you have to draw. Now coming on to the calculative part of the part 4. Determine the y-intercept of the line of best fit. Do not include the absolute uncertainty in your answer. So what we are here calculating the y-intercept, taking point x1, y1 for the best fit, which I have taken the same for the calculation of gradient, that is x1, y1 5, 3.79. Now putting it up in the equation of straight line, that is intercept equals to y minus mx. So y 3.79, m we have already calculated. Here you have to take the complete value, because if you take the significant value, so it will add up to the error. So try to take the value which we have calculated completely before converting it into 3 significant figure. X, that is 5. So by calculating this, we get 3.86024. By rounding off to 3 significant figure, we got 3.86. Yes, we can check with the graph also. 3.86 is the value for the y. This is the y-intercept, and look at the graph I have drawn. This is 3.81, 82, 83, 84, 85, 86. So this is 3.86, that is the my y-intercept. So this is perfectly correct for my readings. Now the D first part, by using your answers to A, C third, C4, determine the value of C and E, include appropriate units if the data given to R is 150 kilo ohm. So we know that gradient is minus 1 upon RC, and gradient we have already calculated, R is given to us, so we can easily find out the value of C. Now doing the proper calculation as shown, you get the value of C as 0.000474, which is very appropriate value, because the capacitance is generally in your microfarad. So I got 447 microfarad. Because this is the value what we are calculating for C, so you should know that C is always measured in microfarad, or you can say the farad is the unit of capacitance. So while writing the answer, you should know the value and the unit of capacitance or any other physical quantity you are calculating. Now for E, the y-intercept is given ln E by R. So by putting the value of y-intercept and E taking E on power both the side, so E raised to power 3.86 equals to E upon 150 into 10 raised to power 3. By calculating the value, we get E equals to 7119802.5 volt, because E is what? EMF, so the value should be in volt. By rounding out to 3 significant figure, we get 712 into 10 raised to power 4 volt. So this is what the value for the E. Now the second part, here the percentage uncertainty in the resistance R is 5%. Determine the absolute uncertainty in C. So G is equals to, that is gradient, minus 1 upon RC. So C will be equals to minus 1 upon RG. Now for C, delta C by C is equals to delta R by R plus delta G by G. Now delta C is equals to delta R by R plus delta G by G into C. So delta R by R is given 5%, so 0.05, plus delta G is the gradient uncertainty that we have calculated in the before part, that is yes, and the C third part we have calculated delta G and the gradient of best fit. So by putting up the values, you should write the complete values for the more accurate value and into C, that is we have calculated in the above part. So the absolute uncertainty in C we get 0.001089. So the up to relevant significant figure we get 0.00011. Now the last part, here we have to calculate the value of, determine the value of I if the charge discharged capacitor by in 2 minutes. So by using this equation and putting up the values calculated, that is E 712 into 10 raised to power 4 volt upon resistance 150 into 10 raised to power 3, and the E raised to power 2 minutes has to be converted into seconds, that is 120 second upon R into C, that is microfarad in the capacitance. So by calculating this, you get this value, and the final result is I equals to 2.121395 ampere. Converting into 3 significant figures, we get 2.12 ampere. So this is the value for the current after the capacitor has discharged through the resistor for 2 minutes. Okay, so this is how we have solved the 970252 Feb March 20 question paper. You can get PDF of this file. The link is given in the description. Now let us consider the marking scheme also. Okay, gradient is correct, y-intercept is correct. These are the values we have already mentioned. Now the absolute uncertainty lies in between this. Yes, our uncertainty is lies between these points. Yes, it is correct. 6 points plotted correctly. This is also error bars done. Line of best fit, points must be balanced. Yes, this line must pass. This is very important. You have to check whether your line is passing between these points or not. Yes, our line is passing between these 2 points. Worst line, acceptable line drawn, error bar drawn, marked, scored only if all bars are plotted. Done. Negative gradient, yes, we got negative with a clear substitution of delta y upon delta x. Gradient, yes, we have done gradient of line of best fit minus gradient of worst fit by using this. Yes, we get the value of y-intercept determining by using this equation. The C gradient we have already calculated. Yes, by using this, it depends, we have done by using this. E determined by using this value. C determined using y-intercept. Yes, it is mentioned correctly. Yes, delta C is also calculated by using this method, and I using the same method. We have used this method, not that. We have used this method. Yes, the values are not given to us, but because of the graphs plotted, it may vary from slightly. So this is how we solve for the question number 2. I hope you like this video. Please share it with your classmates, friends and teachers, and let me know if any improvement possible in the comment box. Thank you.